Hey guys, Mr. Gibson here. I'm going to show you guys how to use the law of sines. This first part, I'm going to show you guys how to find the length of a side using the law of sines. It's useful for non-right triangles when you're given angle, angled side. Quick note here, corresponding sides and angles. The angle that corresponds to the side is the side that's opposite of it. So this is angle A, the opposite side is angle A. This angle B, opposite side angle B, angle C, opposite side angle C, okay? It's helpful because we have this rule that says that these ratios, A over the sine of A, B over the sine of B, and C over the sine of C, you know, those being the sides, the little A, B, and C sides, and uppercase A, B, and C, the angles. Those angles are all, those ratios are all equal to each other. Okay, that's what this means. Broken down, it means this. I can have A over sine of A equals to B over sine of B. B over sine of B equals C over sine of B, C. And then put it all together. A over sine of A equals C over sine of C. Okay. So anyway, let's look at an example here to find the length of a side. Okay. Again, we need angle, angle, sides. So I have angle, angle, or angle, angle, and this side right here. I call this angle B, so this is side B. This is angle C, so the side we're going to find is side C. So I set up the equation like this. C over sine of C equals B over sine of B. C is what we're trying to find. The angle C is 105, so sine of 105 equals side B, which is 7, over the angle, which is 35, sine of 35. Okay, so we set up our equation here. C over sine of 105 equals 7 over sine of 35 degrees. To solve, we're just going to multiply sine of 105 on both sides. Okay, just treat it like a number. Okay, if I had something in the denominator, if I had a number in the denominator, I multiply by that number. Same thing here. We're just going to multiply by sine of 105. Do that to both sides. End up with this. C, now that it's canceling by itself, equals 7 over sine of 35 times sine of 105. Or you could put together with sine of 7 sine of 105 over sine of 35. In the end, C will equal 11.8. So you're looking at me, Mr. Gibson, how do you do that? I'll show you guys real quickly. I'm going to get Desmos out. I'm just going to simply put it in the calculator. I'm going to put this formula in the calculator. Just show you guys how. A little easier to put in the calculator just because you have everything up on the denominator. You don't have to like do an extra step to multiply everything together. Okay, so then functions, I have sine, I go 105, close it, divided by, this is going to multiply the whole thing by 7. Let me fix that real quick. I'm just going to put a parentheses right here, go back here, and there we go. Divide the whole thing, oops. Close this parentheses, divide the whole thing by sine of 35. Okay, I get this number, but I'm going to first make sure that I'm in degrees. Oh, I wasn't in degrees because all this is in degrees, and sure enough, I get 11.8. Okay, next thing. Let's use the law of sines to find the missing angle. Okay. This time we're going to need side-side angle, okay? We'll get to that in a second. Again, the corresponding angles and sides. The thing I'm going to do a little different is I just took the formula and I flipped it, okay? As long as I do it to every single problem, right, every single ratio, it's fine, okay? You can just flip it like that, which is what I did. You're going to see where that makes it a little easier, okay? Again, I got the 3 ratios here. And then I broke down the ratios like that. You can look at that, but all I did was flip it from the previous example, okay? But again, I need side-side angle. So in this example, let's look here. Side-side angle, okay? And I'm going to find this side, I'm going to say side, I'm going to find angle B here because we're calculating the angle. I lost my mind there for a second, okay? So I've set up my equation, sine of B over B, sine of C over C, okay? The the uppercase letters meaning the corresponding angles, to the lowercase letters the corresponding sides, so opposites from the angle itself. So B opposite that, C opposite that, okay? Plug everything in, we're looking for B. I put in 4.7, ignore the red parts for a moment, for the side B. 63 for angle C, side C opposite side is 5.5. To get rid of this 4.7, just like I did in the previous example, multiply on both sides. The 4.7s will cancel. I'm left with sine of B equals this, or more simply put, sine of 63 degrees times 4.7 over 5.5. I get this ratio right here, this number, and that's what sine of B equals. Sine of B equals 0.7614. But what I want is the actual angle measure. So what I'm going to do is I'm going to take the sine inverse, because if you remember, sine inverse takes in the ratio and gives us the angle, okay? And that gives me 49.6, okay? Again, I'm going to get Desmos out just to show you guys where this comes from. And like I did in previous examples, I'm just going to skip having to do this extra step. I'm just going to put everything all in at once. I'm going to put all of this into sine inverse. Okay, so watch what I do here. I'm going to say sine inverse, okay, parentheses, because I'm going to do everything on top. You have sine of 63, close that parentheses, times 4.7, close that parentheses, all over 5.5, and sure enough I get 49.6, okay? So that's how you can use the law of sines when you have side angle to find an angle, and how you can use law of sines when you have angle side to find a side. Thanks for your attention, guys.